So dear students, today we are going to start the last chapter, chapter number 7, that is selection of bearings. Now what we are going to do in this chapter, we are going to have introductions. We have a thorough understanding regarding the bearings, its various types and their numericals, right? Now when you hear the word bearings, definitely you will have an idea. Bearing means ball bearings, right? So basically, bearings have a very unique function in the industries. Let's try to understand the definitions and their functions. Bearing is a mechanical element that permits relative motion between two parts, such as shaft and the housing with minimum frictions. Students try to focus on these lines, right? It defines the bearings and it tell you what is its functions, right? So it's basically permit the relative motion between two parts. This is the requirement of machines, right? Let's say electric motor over here, right? So when you switch on the electric power, what happened? Because of magnetic field, this center armature will rotate, but this armature need to be supported. So though it is supported on the bearings, right? And bearing is fixed in housing. So you can say the bearing ensure free rotation of shaft or the axle with the minimum frictions. So it allow the motion with the minimum frictions because it will save the power, or you can say the loss of energy. That's a function. Now second function is the bearing support the shaft and axle and hold in the correct position. This is most important. If we consider the lathe machines, right? Let's say we have a chuck over here, okay? We are giving the some round bar and then there is a spindle and there is an electric motor, right? If the spindle is not properly supported on the bearings, now here spindle itself need to be aligned, right? When it's rotated, it should not move outward or it should not have offset motions, right? So it is only possible by the use of proper bearings, right? So bearing must support the shaft and axle for the correct positions. If it is not happening, you are not able to get the proper turning diameter, right? So this is also a function of a bearing. It provides the minimum friction motion and also hold the shaft and axle in a correct position. Bearing take up the forces that acts on shaft and axle and transmit to the frame of the foundations. Now this is also a really important functions. Now just try to look at this figure. Here it's a very big drum over here, right? And the person here, engineer, is trying to examine the bearings and its location, right? So it's a very huge bearing over here. So it has to support the material or the component being rotated. Now in this figure, it is the component itself is a rotating drum, which is very heavy. So this force is directly coming on the bearing and bearing is try to transmit that on the frame, right? So bearing does three functions: provide the minimum friction motion, hold the rotating part in correct locations or position, you can say, and also transmit the forces coming on a rotating element, right? So these three things are being carried out by the bearing. So bearing is a very crucial, important component in mechanical engineering. So far machineries are concerned, wherever you find there is a rotation, even your bicycle or you can say a motorbike, car, where there is a rotation of shaft or axle or any other element, you will going to observe that it is supported via bearings, right? Without which it is not possible. Now let's try to understand the classification of bearings, right? Bearings has many types. So first is depending upon the direction of load that is acted, right? So how the load is supported by the bearing. The first is radial bearing and second is thrust bearing. Student, try to understand these two words because this is very important when you move ahead in the next semester. Even in your engineering career, you may be asked to select the radial bearing, thrust bearing. These are the common words that will be speaking during the operations, right? So you should have a clear-cut idea. So the first is radial bearings. The radial bearings, the load act perpendicular to the direction of motion of moving element as shown in figure, right? So element is rotating like this and it is supported on this fixed element, right? So load is acting vertically, that is perpendicular to rotation. So this is referred as radial bearings, right? It is called radial bearing. Now second is thrust bearing, in which the load act along the axis of rotations. Try to understand, the load is acting in this manner, right? But it is rotating like this. So it is taking the thrust. Simultaneously is also allow the rotation of the component. So here the definition or the classification is based on simply the how the load is acting. In case of radial bearing, load act perpendicular to rotations or the rotation axis, and in thrust bearing it is along with the axis, right? So it is act along with the axis of rotation. So these are two basic classification of the bearing. Now it is classified because it is a requirement of machines. Now second classification is depending upon the nature of contact, how the rotating element contact each others, right? So based on that, the first is sliding contact bearing, and second is rolling contact bearing. Generally we have simply idea, that is ball bearing idea, right? Ball bearing no, उसको क्या बोलेंगे भाई, उसको हमारे दिमाग में एक ही चीज़ आती है, बॉल बे जब भी हम बोलते हैं बेरिंग्स तो हमारे दिमाग में बॉल बेरिंग आती है. ऐसा नहीं, इट्स अ वन टाइप ऑफ अ बेरिंग, राइट? सो फर्स्ट इज स्लाइडिंग कॉन्टैक्ट बेरिंग. Now try to understand the difference between the sliding contact bearing and rolling contact bearing, right? Sliding take place along the surfaces of contact between moving element. Now see here the figure is shown, right? So here the shaft is inserted, right? So shaft is also circular, having a smooth surface, right? So here it is also having a smooth surface, so it's support. So there is a contact of surfaces between the moving element and the fixed element. So this is fixed element. It is fixed element, and the shaft itself is a rotating element. The sliding contact bearing are also known as plain bearings or general bearings or sleeve bearings. These are the three names generally used in industry. So sliding contact bearing is also referred as plain bearing. It is also referred as general bearing, or sometimes it is also referred as sleeve bearings. Now here you have to understand, there is no any other rotating element like a ball, right? Here क्या है? Simply you have to understand there are simply circular surfaces which remain in contact. One is rotating, second is fixed. So this kind of bearing where the surface are sliding, try to understand how it operates. So shaft is going to rotate like this, but it is sliding over the inner surface of these bearings, right? That's why it is written sliding take place along the surfaces of contact, right? That is why it is the name is given sliding contact bearing. Now in case of rolling contact bearings, the steel balls, sometimes roller, are interposed between the moving and fixed element. Now try to understand how to get the bearing actions. Or you can say, how can it make it works? You have to fix one of the recess, right? That is outer ring and inner ring, right? We have to fix one. So here it is written the steel ball or roller. So here in this figure we have the roller, steel balls, that is called ball bearing. We refer as ball bearing. If it is having a needle-like structure, we are going to call it roller bearing, right? So these two elements are interposed between the moving element and fixed element. So here depending upon how you are going to fix this element. So here these small balls or rollers are interposed or it is inserted, right? The balls offer rolling friction at 2 points for each ball or roller. So what will happen? There is a contact point over here and there is another second contact, right? So it offer rolling friction over here. Rolling friction is having lower value than the sliding frictions, right? So that's why rolling bearings are widely used in machines. Now here you have to understand one thing. When you compare physically, these intermediate rolling elements are the additional thing with respect to the sliding contact bearing. Here the motion is what? The moving element slides over inner surfaces, right? Here it is rolling over. It is rolling over and moving ahead. That is action is given. So based on that, the name is given rolling contact bearing. Now this rolling contact bearing offer minimum friction with respect to sliding contact bearing. Now let's talk about detail in sliding contact bearing, or you can say the plain bearing, right? So I'm going to discuss in detail about the sliding contact bearing, where the motion between two elements is a sliding of a surfaces. Now the surface of the shaft slides over the surface of the bush, resulting in friction and wear. So very simple definition here. If I draw the shaft over here, right, like this in 3 dimensions, okay. So when it's rotated, it slides over these surfaces, right. So in order to reduce the friction, the two surfaces are separated by a film or lubricating oil. So lubrication is very important, right? It will separate the two surfaces and reduce the frictions. The bush is made up of special bearing material like white metal and bronze. So this is general construction of plain bearing. You will find there is a one is shaft, second is the sliding surface, right? So here, if you look at the another figure, we have a lubricating oil shown over here, right? So this is shaft which is rotating, and this is the bearing, or you can say the simply sometimes we refer as bush. Okay, bush is an additional cylindrical piece used to take care of wears. So what are the applications? Where do these sliding contact bearings basically used? So it is used in crankshaft bearing in petrol and diesel engine. Whenever you get the chance to visit the maintenance department of the automobile industry, you find that in case of heavy engine, the engine is supported by using these plain bearings, not by the ball bearings, or you can say the rolling contact bearings. It is also used in centrifugal pumps, large size electric motors. I repeat, large size, not small size, right? Steam and gas turbine. Again, this is a large construction. Now you can say the large equipments. Concrete mixtures. Now here, when you say concrete mixture, means it has weight, or you can say the loading. So concrete mixture, when you mix the one batch of bag of cement, then the sand and the water, it weighs around at least 150 to 200 kg, even more than that, right? Depends how much you are adding in, right? So it's a heavy structure, it's a heavy loading. So wherever there is a sliding, there is a requirement of heavy loading support, you are going to use the sliding contact bearing, right? Now rope conveyor, marine installation, these are the applications where generally the sliding contact or plain bearing is used. Now in plain bearing, the common thing is you have to use the lubricating oil, right, to reduce the friction. This is a requirement. If you do not use it, there are going to be direct metal contact, right, and that result in heavy friction, or it may generate the heat, and it may happen that your component get jammed, right? So to avoid this, to avoid the loss due to frictions, a lubricating oil is must in a plain bearing. Now, types of sliding contact bearing based on contact. Now again, we have a classification of sliding contact bearing, which is a type of a bearing, right? Now the first is the sliding contact bearing, in which the sliding action is along the circumference of a circle. Very simple. Let's try to understand. Shaft is always circular, right? And the supporting surface is also circular. So here the sliding action is along the circumference of a circle. It is rotary. It try to say it is a rotating in nature. And an arc of circle and carrying the radial loads are known as journal or the sleeve bearings. Now this is very important. Try to understand. The word is given journal or the sleeve bearings. Whenever there is a carrying a radial loads, so load acting perpendicular to the axis of rotations, right? And there is a action of like this, sliding action. What kind of? Where it is circular actions like this, circular actions, right? It try to rotate in either left or right. It try to slide over the another fixed element surface. Now based on that, we have three classifications. Second is full journal bearing, partial bearing, and fitted bearing. But how they are different from each others? So this journal bearing, when the angle of contact of the bearing with journal. Now what is journal and bearing? Try to understand. Journal means shaft. It's a synonyms used in plain bearing, right? So shaft is referred as journal. Now it's not a journal that we write in physics chemistry laboratory in 12th science, right? It's not that journal. It's a journal, its name is given in plain bearing, that is synonyms to the shaft. And the other surface, which is fixed surface, which support the rotation of this journal, is called bearing, right? So journal bearing. So when with the journal is 360 degree. So whenever there is a contact of this journal, that is shaft, with the bearing around the 360 degree, then the bearing is referred as full general bearing. Means contact is being carried out at 360 degree. It can contact around all the surfaces, right? This type of bearing is commonly used in industrial machineries. See, the word is very important. Industrial machinery means a load, a good amount of load, right? To accommodate bearing load in radial direction. This is again important word. Whenever you use the full general bearings, that means they're going to be a good amount of load acting in radial directions. So industrial machineries basically employ these full general bearings to support the shaft and the load. When the angle of contact of the bearing with the general is 120 degree, let's say the fixed element is now supporting the general, that is shaft, by 120 degree only, not by 360 degree. Okay. Then this type of bearing is called partial general bearings. Now you must have you might have a question in mind why we have this type of classification. One is full general, partial, then fitted, right? So why? Because then the bearing is said to be partial. This type of bearing is less friction. This is what the requirement, right? So when the load is moderate and it is acting in particular direction, downward direction, then you do not require to support this general or the shaft by remaining surfaces, right? You do not require to support the shaft around all the circumference. It is sufficient to support by this bearing surface. जिसके ऊपर लोड आ रहा है उसको ही सपोर्ट करना है. ये सरफेस किसी काम की नहीं है, अभी उसके ऊपर लोड नहीं आ रहा है. That's why we are supporting the partial part of the rotating element. So due to this, it offers less friction. Always remember, being a mechanical engineer, we need to minimize the friction in certain applications, most of the machinery applications, right? So this is one of the solutions. So less friction than the full general bearing, but it can be used only where the load is always in one direction, as I stated, right? If it is coming in the upward direction, it will come out, right? There is no support from this direction, right? The most common application of the partial general bearing is found in railroad car axle. Now student try to search this word in Google and find out the images. It is really applied or not, right? So railroad car axle, where it is load is in one directions, right? Now third is the full and partial general bearings may be called clearance bearing. Now these two, that is first option, full and partial general bearings are also referred as clearance bearing because the diameter of the general is less than the bearings, right? Definitely to allow the use of lubricant oil and the free motion, you have to have some clearance between, or you can say dimension difference between the shaft and the bearing, right? So because of that clearance, these two bearings are referred as clearance bearing. Now third one is when partial general bearing, I repeat, when the partial general bearing has no clearance, that is diameter of the general is equal to bearing then the bearing is referred as fitted bearing as shown in figure C, right? So what does it mean? Both the diameters are equal, means this diameter, this radial and this one. So both this curvature have a common center, right? So those kind of partial bearing is referred as fitted bearing. In second figure, you may see that the centers are not matching. Here there is a two difference center mark, right? So this is referred as partial general bearing. But in this case, where you have to have the same diameters, means their center are matching, right? Or coinciding. Now types of sliding contact bearing based on thickness of layer of lubricant. Now see, we have again classification of same sliding contact bearing. One was based on how the contact is happening, whether it is full circumference contact, then we are going to refer as full general bearing. If it is having a 120 degree kind of a contact, we are going to call it partial general bearing, right? Again, these are the classification of same sliding contact bearing. Now again, we are going to classify the sliding contact bearing based on lubricating layer thickness, right? So based on thickness of layer of lubricant. The first is thick film bearings. Now what is it? The thick film bearings are those in which the working surfaces are completely separated from each other. The words are very important during rotations. When the rotating element and the fixed element are separated by the lubricant oil or the layer of oil by the lubricant, such type of bearing are also called as hydrodynamic lubricator bearings, right? This is, try to understand, very important, right? So whenever there is two elements, one is rotating, one is fixed element, are separated by lubricant oil all the time. I repeat, all the time during operation, such bearings is also referred as called as hydrodynamic lubricative bearing. It is also referred as thick film bearings. So under the thick film bearings, hydrodynamic lubricating bearing is referred, right? Now second is thin film bearings. The thin film bearings are those in which although lubricant is present. See, try to catch the statement. Although the lubricant is present, it is there. The working surface is partially contact each other at least part of the time. So here the surfaces are in remain contact, but the lubricating oil is also remain present. But they are separated, or they having working surface are partially contact with each other. It is not fully contact, right? So such types of bearing are referred as boundary lubricator bearing, right? So whenever there is a requirement, there going to be a small lubricating layer, right? It is not having the complete covering of the lubricating over the entire surfaces, right? So whenever there is a requirement of contact, there the lubricating oil is available, right? And that is referred as boundary lubricator bearings. Now third is zero film bearing. The zero film bearings are those which operate without any lubricant, means no lubricant use. You can say dry bearing, you can say, right? So it's a very dangerous situation. It's very difficult. It's going to result in what? The heavy friction, heat generation and jamming at the later stages. Again, it depends on type of load. Now the hydrostatic or externally pressurized lubricating bearing. Again, this is a part of simply sliding contact bearing. We are simply classifying based on the lubrications. Okay. The hydrostatic bearings are those which can support steady loads without any relative motion between the journal and the bearing. This is achieved by forcing the external pressurized lubricant between the member. Now hydrostatic means what? And hydrodynamics means what? Whenever there is a motion between two elements, that is shaft and the bearing, or can say journal and bearing, due to the rotation, the journal itself is lift off and it is try to rotate in a way that it is remain in the center of the bearing, right? So it is separated by most of the time the lubricating oil. So this is because it is in motion, we are going to call dynamic situation. Here lubricant exists because of the motion. So we are going to refer as hydrodynamic lubricated bearings. But there are bearings where the lubricants are forced with the pressure. So because of that, even the machines or the shaft is not in motion, still it support the load. So that's why the hydrostatic bearings are those in which the supports the steady load, means there is no motion, still load is being acted, and but it is tried to separate the shaft and the bearing. So it is only possible by forcing the externally pressurized lubricant between the members. So this kind of bearing is referred as hydrostatic bearings. Now, what are the general material used for plain bearing only? Try to understand. We are talking about only plain bearings, not the ball bearing and the roller bearing. The first material is referred as baby metal. Now, what is exactly the tin base and lead base babies are widely used as a bearing material. You might have seen the yellow kind of bush, right? Or sometime kind of silky or the gray type of cylindrical surface inside the engine, right? So these are used as a bearing surfaces. So because they satisfy most requirement for general application, it is used in automobile industry as a thin layer, that is 0.5 mm to 0.5 mm thick, right? So it helps to provide, it simply try to reduce the frictions between the piston and the cylinder. Now what is this basically? So tin base having 90% tin, then 4.5% copper, and antimony is 5% and lead is 0.5. So this is the content of this tin-based babbitt material, right? If you want to make a lead-based babbitt material where the percent of lead is replaced by the tin, that is 84%. Tin is used 6%, antimony is 9.5, and copper is 0.5. So these are called babbitt materials, right? Now second is bronze, right? Bronze is simply alloy of copper, tin and zinc, are generally used in the form of machined bush. Try to understand. Wherever you see the bush, that is a yellowish part in cylinder or maybe the rotating element, right? It is used to easy replacement. Now see, try to understand, over the period of rotation, there going to be a wear, right? So because of wear, the inner part of the bearing is going to expand or enlarge because of the removal of material. So deliberately bush is used over there, and bush is cheap to manufacture. So bush is replaced, not the entire the bearing surface is replaced. So this will save the time, right? So bush are pressed into the cell. The bush may be in one or two pieces depending upon the construction. The bronzes are commonly used for bearing material are gunmetal and phosphorus bronze. These are the name given, gunmetal and phosphorus bronze, but they are simply bronzes, right? So gunmetal is made up of 88% copper, 10% tin, zinc is 2%. Phosphorus bronze, in which the copper having 80% contribution, 10% of tin and 90%. Now gunmetal basically for heavy load up to 10 megapascal bearing pressure. So this is very heavy, right? And phosphorus basically again go beyond that limit, very, very heavy load, that is 14 megapascal bearing pressures. So it is used where the bearing pressure is more than 10 or even higher. Now third material used for the bearing is cast iron. The cast iron bearings are usually used with the steel generals. See, general means what? Again, shaft. General means shaft. Do not confuse, right? General means shaft. So whenever there is a steel shaft to be supported, so cast iron material is widely used, right? So such type of bearings are fairly successful where the lubrication is adequate and the pressure is limited to 3.5 Newton per millimeter square. So here you can compare the bronze material is going to take very heavy pressure, but cast iron going to take a minimum pressure, or you can say the moderate load conditions, right? So it is used when there is a steel general is used, right? And you have to provide the lubrications. It is a requirement, okay? Now fourth is a silver material. The silver and the silver lead bearings are mostly used in aircraft engine. Now see this again applications. You cannot replace the silver material or cast iron with each other, right? It's a specific requirement of engine where the fatigue strength is the most important considerations. So cast iron is very poor in fatigue, right? So it cannot be used in aircraft engine, but the silver is very good, having a very good strength in fatigue, right? So it offers the good fatigue strength. So that's why it is mentioned over here. Now the last material is in the plain bearing is the non-metallic bearings material, right? So the various non-metallic bearings are made up of carbon graphite. See, try to understand, it's a non-metallic material, carbon graphite, rubber, woods and plastic. The carbon graphite bearings are self-lubricating. Self-lubricating means, let's say, try to understand, take the example of pencil, right? Pencil having lead. Now lead, when you write it, you will feel smooth buttery actions or the touch sensation, right? So that is because each layer of carbon is moving relative to each others, right? So these result in, you can say, the carbon graphite bearings are going to give self-lubricating bearings actions, right? So you do not require additional lubrication from the outside. So it is dimensionally stable over a wide range of operating condition. It is used in food processing. See, try to understand, it is used in food processing equipments. The wood bearings are used in many applications where the low cost, cleanliness and inattention to the lubrications and anti-seizings are important. So when the application is not that much so important, right? So you want to minimize the cost and you are not interested to maintain the lubrications, right? There you can use the wood bearings. But this wood bearing cannot be used in industrial machines. Now the third material which is non-metallic is soft rubber. Soft rubber bearings are used with the water and other low viscosity lubricants, partially where the sands and other large particles are present, right? So if the sand particle are present, it is likely to dig or stick into the materials, right? If there is a requirement like this, then you have to use the soft bearing material. The rubber bearings are excellent for absorbing shock because rubber is known for that, right? So it is going to absorb the loads and vibration. Rubber bearings are used mainly on marine propeller shaft. This is specific applications, right? It is going to absorb the load and shock. Hydraulic turbines and the pumps. The commonly used plastic material for bearing is nylon and Teflon. Many times you have seen that the bearing is of white color, right? So that is nylon, right? It's called nylon material. So wherever there is a requirement like this, okay, क्या है कि भाई लोड को भी एब्जॉर्ब, शॉक को एब्जॉर्ब करना है, ठीक है, वाइब्रेशन को एब्जॉर्ब करना है, देन यू आर गोइंग टू चूज दिस काइंड ऑफ मटेरियल्स. These materials have many characteristics desirable in bearing material. Both can be used dry, that is zero fill bearings, right? So you do not require any kind of lubrications. So in most of the cases, when you choose a non-metallic material as a bearing, you do not require additional lubrication. So that will be referred as zero fill bearings. Now let's talk about the property of bearing material, right? Sorry. Now try to understand the requirement of bearing materials. The first is compressive strength. Just go, let's recall the image. Now here the load is going to act on it, right? So it's a compressive load where in bearing, basically whenever there is a bearing operations, the rotating element is going to compress against the fixed element. So compressions is a basic action or the movement that you come across, right? So strength is required in compressions. So compressive strength, the bearing material should have a high compressive strength. Now what does it mean? It should not get crushed because of compressive load. It should not develop any kind of yielding, should not have a change in dimension due to the compressions. So that much strength has to be there. So you should have a high compressive strength to withstand the maximum pressure, so to prevent any extrusion or the permanent deformation of the bearing, right? So if this is the bearing like this, let's say, and shaft is coming out, right? So because of load, the bearing surface should not get enlarged, So very important thing is that because of in bearing, generally the compressive load is going to come, right? So two surfaces are going to support each other. So they're going to be a compressive actions. So you have to have a good amount of compressive strength. Otherwise, what will happen? The bearing surface get deformed. In here, in plain bearing, what will happen? The supporting surface, that is the bearing, not the general, is going to enlarge because of loading situation, right? So that should not happen. If it happens, enlargement or permanent deformations happen, the rotation of the shaft is going to getting the eccentric because of the centrifugal force, and that going to create very noisy operations. So whenever you come across like this noisy operation, that you have to focus on the bearing conditions, right? So now second requirement is fatigue strength. The bearing material should have sufficient fatigue strength. Now why? So that it can withstand repetitive loads. Now try to understand let's recall the figure first, okay? So load is acting. So load is, let's say, supported over here. Every time when the shaft rotates by each degree, the new surface comes in contact and take up the load. So it's a reversible loading for each section. It's a reversible loading. So this itself defines the fatigue actions, right? So with repetitive load without developing surface fatigue crack, it is a major importance in aircraft and automotive engine. Now, why aircraft? Aircraft is simply floating in the air. If engine stops because of this failure of bearing, you know what are going to happen. They're going to be a direct accident, right? Fatal casualty, right? So it is not allowed. So here, whenever the bearing is used in aviations or the aircraft engine, it must have sufficient fatigue strength. So basically, aircraft and automobile engine must have the bearing used in these two industries must have a good fatigue strength. Third is conformability. What is conformability? It is the ability of bearing material to accommodate shaft deflection and the bearing inaccuracy. Now, see, this is very important. Many times what happened because of machining, there may be some variation in dimension of shaft, right? So bearing during the rotation or operation should able to take these variations. So it is simply ability of bearing material to accommodate shaft deflection. अगर कुछ डिफ्लेक्ट हो रहा है तो it should able to support it, should not allow to enlarge it, right? So it is going to take up, it is going to accommodate that deformation. So by plastic deformation or creep without any excessive wear and heatings. So this is again the properties of material required. So it may deform, but is not going to form any crack or not going to create any excessive wear and heating. So slightly deviation or deflection of shaft is taken care. That property of material is referred as is conformability. The fourth is embeddability. It is the ability of bearing material to accommodate or embed small particles of dust and grits, or you can say the sand particles, without without scoring the material of generals, right? Now see, the bearing material, that is this static part, due to this embeddability property, if because of dust is simply floating in environment, it may settle over here, right, with the lubrication oil. So it during the motion, these dust or grit particles should embed, means should get stuck in a bearing material, should not come out, should not create any scoring. Scoring means को क्या बोलेंगे? A kind of a lining marks on a material, right? So without scoring the material of general means shaft, उसके ऊपर वो क्या करेंगे? उसको स्क्रैच नहीं करने देगा. So because of this, it is going to retain, it is going to embed this particle because of this property, right? Now fifth is bondability. Many high capacity bearings are made up of bonding one or more thin layer of bearing materials. This is the requirement, specific requirement applications, right? So more than two materials are bound together to a high strength steel cell, right? So bonding more than one material together by thin layers. So thus the strength of bond, that is bondability, is an important consideration in selecting bearings. So if this is the requirement, then you should think that the two materials which are used to make a composite material, a composite bearing material, right? So they should have a proper bonding, right? So because of that, it offers very good strength. So this bondability property is very important in selecting of bearing materials. The sixth is corrosion resistance. The bearing material should not corrode away under the action of lubricating oil. You know, हमें पता है कि भाई जब corrosion लगता है तो क्या होता है, लॉक ओपन नहीं होता है, बेरिंग रोटेट नहीं करेगी, राइट? सो बिकॉज ऑफ प्रेजेंस ऑफ lubricating oil, it should not develop any corrosion. So anti-corrosion property is required. So the bearing should have enough corrosion resistance under the action of under the presence of lubricating oil, right? So this property of particular importance in internal combustion engine, very important, because inside the engine you have to lubricate the shaft and bearing to minimize the friction and hence the power loss, right? So lubricating oil is always direct in contact with the bearing material. So bearing material should not react and develop any kind of a corrosion. So seventh property is thermal conductivity. The bearing material should be of high thermal conductivity so as to permit the rapid removal of the heat generated in frictions. Right now, also take the case with the internal combustion engine, where there is a frequently burning of fuel is going on. So heat is transfer from the cylinder, piston, and connected to the bearing as well, right? So material should have a thermal conductivity. Otherwise, what will happen? Because of the high temperature, the material expand, that we know, right? And hence, just try to imagine if the outer ring of the ball bearing expands. So what will happen? There is not going to be have a enough or accurate contact of the ball between the two rings, right? It come out, right? So here we need to take care of the high temperature situation, right? So material should have a good thermal conductivity. So it is not going to gather or accumulate the high heat energy, right? It is rapidly removed from its surfaces. So try to keep the cool, right? So hence the expansion of the material is limited. And also the heat is generated due to frictions. So this heat must be dissipated very fast, and it is only possible if you have a very good thermal conductivity property. Now the last is thermal expansion. The bearing material should be of low coefficient of thermal expansion. Let's start with it is again, it is connected with the same thing. If you do not have a thermal conductivity, let's try to understand with example. Let's say this is steel rod, okay? When you heat it, its temperature increases, right? So because of that, it expands, its length increases, let's say by delta L, okay? If it is have a good thermal conductivity like aluminum, copper, it will disseminate the heat energy into environment very fast, right? So upon removal of this heat load, it will come back immediately. It will regain its position. But here, the thermal expansion that is happened because of the heat material. If this bearing material do not have a thermal expansion or have a high thermal expansion, what will happen? Even slight change in temperature, it will expand. It changes its dimensions. Try to understand. This outer ring may develop the small change in the you can say the diameter value, right? So thermal expansion, if it occurs due to the heat, due to the low thermal conductivity, it going to be affect the operations. So when the bearing operates over a wide range of temperature, there is no undue change in the clearance, right? So it's very important. The two elements are very finely running with respect to the diameter difference, right? But because of these two properties, thermal conductivity and thermal expansion, it may increases. So we need to avoid this. It is only possible by two things. One is thermal conductivity, the second is thermal expansion. Now here you may raise the questions because these two things are connected. If thermal conductivity has to be higher, definitely it is going to create a more thermal expansion, right? So here it is little bit contradictory. To have a poor thermal expansion, you have to use a material which does not have a good thermal conductivity, right? But by allowing the material, you can achieve both the thing. You can increase the thermal conductivity, but you can also same time have a lower coefficient thermal expansion. So both the goal is achieved. And this is required because you just simply try to imagine even slight change in dimension of ball bearing, it makes it useless. It cannot be, it's going to create a very heavy sound, right? You will immediately detect yourself that there is something wrong in the ball bearing. So this may happen due to the thermal conductivity or may happen due to thermal expansion, right?